We're going to look at a couple more demonstrations of rotational inertia. Now, to review, rotational inertia is the property of an object that deals with a resistance to a change in its state of rotational motion. We know that this depends upon the mass of the object and the way that mass is distributed from the axis of rotation. For the first demonstration, let's look at this aluminum disc. This has quite a bit of inertia because much of the mass is distributed far from the axis of rotation. We're going to put this in motion with a motor and let it spin while we're doing something else. And it will take some time to spin down because of its large inertia or rotational inertia. So I'll get this thing going. I'll let it spin up here for about 5 to 10 seconds. And I've turned the motor off now, and now it's just slowing down. Now, it will slow down because there's frictions in the bearings, but it's going to take a while to do that because of its large rotational inertia. While that's happening, let's take a look at this demonstration right here. Here I've got two discs which have the same radii. One of them is an aluminum ring, and the other is a piece of wood. Now, if these have the same mass, they have the same inertia, but they don't have the same rotational inertia because that mass is distributed in a different way. For this, the mass is distributed uniformly throughout. For the ring, the mass is all distributed far from where the axis of rotation will be, which is going to be right through the center. And so this will have a greater rotational inertia than this wooden disc. What we're going to have them do is race down this incline. And the one with the greater rotational inertia will lose the race because it will have a greater resistance to a change in its state of rotational motion. Now, right now, the state of rotational motion of both objects is 0. They're not rotating. Once I remove the piece of wood, one of them is going to rotate more quickly. Let's see which one that is. So the wooden disc rotated more quickly and won the race down the incline. That makes sense because we said that the metal ring had greater rotational inertia, so there's a greater resistance to a change in its state of motion. It's going to have a smaller rotational acceleration as it goes down the plane. Let's take a look now at our disc. You can see that it's still turning. It's slowing down, and it's almost stopped by now. But if we could make the friction in the bearings much, much less, this could continue spinning for a long period of time. If we made this a very large metallic disc, we could store a large amount of energy, rotational energy, in that disc, and we could keep that energy stored for a long period of time. Such devices are called flywheels, and they are used exactly for that purpose, for energy storage.